So this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. It says find the rate of change between 8.2 and 5.11. So remember from our last video, rate of change is just a fancy way of saying slope. And in our last video, we talked about finding rate of change or average rate of change when we had a graph. So, I mean, we could get some graph paper and graph these 2 points, then do rise over run, but there's a much faster way to do this. We can use our slope formula, which hopefully we remember writing down from our last video. It's y2 minus y1 divided by x2 minus x1. This means the exact same thing as rise over run, because in the numerator, we've got the change in the y direction, and in the denominator, we've got the change in the horizontal direction, the change left and right. So let's label this. So it's x1 is 8, y1 is 2, x2 is 5, y2 is 11, and then we're just going to plug in to our equation. Let's see what we get. So y2 is going to be 11 minus 2, all divided by x2 is 5 minus 8. Now keep in mind, when you use this formula, you can do y1 minus y2, but if you're going to do that, you better switch the x's as well. Most textbooks write this as y2 minus y1 over x2 minus x1, so that's the way I'm going to write it. But you can switch the order as long as you do it in the numerator and the denominator. So just keep that in mind as we go forward. Let's see. Let's simplify. So 11 take away 2 is 9. Divided by 5 minus 8 is negative 3. Divide that, we get negative 3. And there's our rate of change, our slope between those 2 points, between those ordered pairs. Let's take a look at our video today. Today we're doing chapter 4, section 2.5. Again, this will be the last video we spend on this section, and after today we should be able to find the average rate of change between 2 points of a function algebraically. So it's almost the same objective as our last video, but now instead of working graphically, we're going to be working algebraically, which some students think is easier, some students think is a little bit more difficult. It all depends. It all depends on where your strengths lie, if you're more of like a visual person or more of like a algebraically minded person. So let's take a look at example 1. It says let h of x equal the absolute value of x plus 2 minus 3, and we have to find the average rate of change of the function h of x between x equals negative 10 and x equals 0. All right, well, this is very similar to the problems we saw in our last video, but we don't have a graph. I mean, so we could graph it or use a graphing calculator or something like that, but I think there's going to be an easier way to do it. So let's talk about, okay, what made the warm-up so simple? Or at least simple compared to this one. What made the warm-up a little easier is that they gave us 2 ordered pairs. They gave us the starting point and the ending point. Here they're giving us the starting x and the ending x, but we don't have the complete points. But if we were able to find the 2 points, then this would be just as simple as the warm-up. And if we have an x value, how do we find the y value that goes with it? Well, hopefully we remember, we just take our x and plug it in. We substitute it in. So let's plug in negative 10. So that's going to be h of negative 10, just plugging it in right to that function they give us. That equals absolute value, well, not x anymore, because we know our x value is negative 10. Then we just copy the rest, plus 2 minus 3. Now all we have to do is simplify, and that will give us our first complete ordered pair. So let's see what we get. That's going to be the absolute value of negative 8 minus 3. Let me scroll down a little bit. So we get h of negative 10 equals positive 8 minus 3, so we get 5. Which means our first complete ordered pair is going to be negative 10 and 5. So that's our x1 and y1 that we can plug into our function. Plug into our formula for slope, our formula for average rate of change. Now we're going to do the same exact thing with x equals 0 to find our ending point. So it's going to be h of 0 equals the absolute value of 0 plus 2 minus 3. If you can skip some of these steps on your own, that's a good thing. I'm just showing all my work. So we get h of 0 equals the absolute value of 2 minus 3, which we know the absolute value of 2 is just 2. Take away 3, and we get negative 1, which means our ending point, our second ordered pair, had an x value of 0 and a y value of negative 1. So that's our x2 and y2. And we just take those values and plug them into our slope formula, which we remember was y2 minus y1 over x2 minus x1. I'm not going to write that formula every time, but hopefully you remember it. Where were we? So y2 is negative 1 minus 5, all divided by x2 is 0, minus, it becomes plus 10, because minus a negative 10 is a positive. And then we get negative 6 over 10. We can simplify that by dividing by 2, and we get negative 3/5. That's our answer for the average rate of change of that function between x equals negative 10 and x equals 0. So really, all we have to do here to make this problem, or these types of problems, just as easy as the warm-up, is whatever x values they give us, plug those in to find your points, and then you just use your rate of change formula. That's it. Let's do a couple more just to make sure we have this. So it says let h of x equals x squared or equal x squared minus x plus 7. Find the average rate of change of the function h of x between x equals negative 4 and x equals 5. Well, to find the average rate of change of something, if we're given the function, or the function rule, I should say, we can just find our two ordered pairs. So let's plug in negative 4. So let's see, it's h of negative 4 equals, let's skip some of these steps on our own. I think we can handle doing some of this in our head. So it's going to be negative 4 squared, which is positive 16, minus the negative 4 is plus 4, plus 7. So that comes out to h of negative 4 equals 20, and 20 and 7 becomes 27. Got a little tongue-tied there. Which means our first point is negative 4, 27. So that's x1 and y1. Now we just need our ending point, which means we plug in 5, let's scroll up. So h of 5, again, let's skip some of this. So 5 squared, that's just 25, minus 5 plus 7. And we get h of 5 equals 25 minus 5 is 20, plus 7 is 27. So our ending point is 5, 27. That's our x2 and our y2. Now we just take those numbers and plug them into our formula, which was y2, 27, minus y1, also 27, divided by x2, 5, minus x1, which becomes minus a negative 4, which is plus 4. And we end up with 0 over 9, giving us a rate of change, or an average rate of change, I should say, of 0. Now, if we really understand what rate of change means, we actually could have skipped this step completely. As soon as we saw that our starting point and ending point had the same y value, essentially had the same height, well, then we could say, well, between those 2 points, there's no average rate of change because the height stayed the same. But I mean, if you need to plug it into the formula, what, it takes an extra 30 seconds of your life and you still get the answer correct. Just want to show you 2 different ways to think about these problems. Last one, I want you to try this one on your own. I know the function looks a little bit more intimidating, but I think you can handle it. Going over to 3, 2, 1, let's go. Let f of x equal negative 0.4 times 2 to the x. Find the average rate of change of the function f of x between x equals 0 and x equals 4. Well, we've got to find ordered pairs. Whenever we're given x values, to find a corresponding y value, we just plug it in. So f of 0 equals negative 0.4 times 2 to the 0 power. If we remember our exponent rules, we remember that anything to the power of 0 is just 1. So f of 0 just equals, we'll just put it here, negative 0.4. So our starting point is 0 and negative 0.4. It's decimal, but we can deal with decimals. That's our x1 and y1. And we do the same thing to find x2 and y2, but this time we substitute in x equals 4. That becomes f of 4 equals negative 0.4 times 2 to the 4th power. Let's see if I can do this in my head without making a mistake. Negative 0.4 times 2 to the 4th power is just 16. That's just 2 multiplied by itself 4 times. Then we get f of 4 equals, let's see, it's definitely going to be negative. So let's see. 0.4 times 10 is 4. 0.4 times 6 is 2.4. So that would be a negative 6.4 if I'm doing that correctly in my head. I think I am. I forgot to put f of 0. Put that there. So now let's go back to our green and find the second point. Got distracted there with the f of 0. So the x value was 4, and the y value we found once we plugged it in was negative 6.4. That is our x2 and y2. Now we just plug it into our formula for rate of change, or formula for average rate of change in this case, even though it's the same formula. So it's y2, negative 6.4, minus y1 becomes a positive 0.4, minus a negative is a positive, divided by x2 minus x1, so it's just 4 minus 0. Let's see here, negative 6.4 plus 0.4, that's just negative 6, divided by 4 minus 0 is 4, and we can simplify that by dividing both of them by 2, negative 3 over 2, and that's our answer. Hopefully that's what you got on your own. If not, just look at the work, compare it, see where you went wrong. That's always how we want to do when we make math mistakes. And there's nothing wrong with that. I make mistakes all the time when I'm learning math that's new to me. Sometimes doing math that's not new to me. All right, so here's our homework for this video. Just one problem. Just one problem. So it's a bit of a lengthy word problem. I know it probably looks like, wait a minute, we didn't do anything like this, but just because there's more words and more information doesn't mean it's any different, right? So this problem is exactly the same type of problem as what we just did. They just sort of put how do I want to say this? They put like little window dressing around it to make it look more complicated. Just attack this problem the same way you would any other word problem. Okay, what are they asking? What information are they giving me? And where do I go from there? As always, if you have questions, let me know. Enjoy the rest of your day.